So the third option what we have is the board, that is it joins the selected polylines by extending or trimming if possible, or else it joins by adding a straight segment between the nearest point. That is, it will try and execute a combo of both the extend as well as the add mechanism to give out the end objective. So now let us, for instance, we'll try use the extend option first, and once extend option is done, what we can do is we can specify the approximate first distance. Consider, let's say, like 100 units. See, now it get extended because in the same line we can see this object here. So now let us just undo and see how the other command works in. So we'll go to the p-edit object and select multiple commands again, and select these two by the cross fencing option. Now again the option to convert to polyline, yes, go to join, and now join type as add and say a first distance of 50. So in that case, again, as they are coincident, they take and directly join the segment. So now let's consider a different point that does not coincide with this object. So that is, let us draw a line something like that. That is, it does not merge directly here. So let us see how the algorithm looks into this concept. So let's select these two lines for multiple. Select this object, convert to spline, use the join command, and let us use the same command, but this time let us use both the options. Let's see how the object is merged. So for the same first distance of 50, you can say based on that it has added one more segment. So instead of extending, it constitutes the add command in order to close the polyline. So this is how your join command is going to work based on the different join types. So next, the option what we have is the width command. So now let's look into this. So width, once we done it, so it asks for this line width for the entire command. So suppose if the line width is say like 2 mm, now all the line is get adopted as 2 mm as uniform one. Whereas if you want to go to the default one, 0 is the default width of the AutoCAD system. Next, have an option to fit a smooth curve that runs along the polyline vertices. So that is done by the fit command. So once it's done, the object that we had get converted to a smooth curve respective to the tangent direction of the available vertex points. So this curve is going to consist a pair of arcs, that is, each and every segment is going to be arc segments joining the vertices together. So suppose if there are any special requirements, then the software also does introduces new vertex to solve it. So let us use the U command, that is undo, to come back to the original point. So right now what you can see is this was the object. So the curve was done by modifying these vertex into a curve. So we got an arc here, and an arc here. But in order to introduce this, it introduced one more vertex. So let us look into the fit command again. You can see it introduced one more vertex to make this point as a smooth curve. So this is the option of the fit command. So next what we have is a spline command. So this option uses the vertex of the selected polyline as the control points or the frame of the spline curve. So this will be used to open or closed based on the original polyline. So this curve will pass through the first and the last control point. That is, as is the open end, this curve will pass through the first and the last vertex point, and it does not imply that it has to pass through all other vertices. Only the start and the end points are relevant, wherein it gets pulled towards the other points without passing through them. So if we also specify more control points, then we can have a full effect on the curve. So let us look into it. When we click on spline, you can see that the object, the start and end point is remain same, but a smooth object is given. So in order to have a quick understanding, let us duplicate this curve using a copy command, and again we'll specify the same base point as here. copy. Okay, so just for ease, let us keep it as 0.1, or the base point to be 0 and angle to be 0. So you can see we have created an object that will overlay on it. So with this command, now let us use the p-edit option to look into how the spline curve is going to operate on it. So now you can see the original point persisted. So what it does is the source point and the end point is maintained the same, whereas this spline will tend to be pulled towards the vertex point. These vertexes of the original curve tends to act as a control point, and thereby it will control this spline curve. So using this spline, actually we will be getting two type of splines, that is either a quadratic B spline or cubic B spline. So these curves will be different from what we are currently using, this fit curve. So there's a separate option called as a spline variable. So that will look in the subsequent curve. So once we use the spline curve, we also have an option called as a D curve, that is to revert the polyline to its original state. That is, instead of spline, it will go back to the original state of the polyline. So now you can see that we didn't have this information. This is the original line, whereas this was created after recurving. So this D curve removes all the curvilinear objects that are present here and gives us only a linear object. That means this curve element is removed and then replaced by a linear object. So this is what the decurve command does. So next command in the pedit is the line type generation. So this line type generation will act only on a continuous pattern type of line, that is not in the straight line. So we have to modify this onto a dashed line or a hidden type of line to understand this implication. So towards that, first let us remove the duplicate copy that we have. So right now we have only one element here. I have removed the other one. So now by selecting this and going to the properties, let's change the line type to be a, say, a center line type concept. So we'll zoom on to one of the vertex to see how the line type generation happens. So this is the basic type of line type that we have. So now when we go to the pedit command and using the line type generation, we'll be getting a boolean type of requirement, whether off or on. So by default, when it is in off state, this option generates the line type starting and ending with a dash at the vertex. So it means that we have a at each vertex, if you see, we have a dash here. So when we change the option to in on state, now each vertex will have the smaller line segment there. At this join point, you can start it from the, it's not a perfect longer line, but rather with the pattern that is running through the vertex as required. So this is the line type generation command. This is just a kind of a region command that will help you to optimize the view that you want to have. Suppose you does not want the end point to be like this, that is, it has to be ensure that it is of continuous segment, then you use this to show the sharp vertexes that you have. So this is the major use of the line type generation command. So let's look into the next command, the reverse option. In between, I also would like to highlight the other way of selecting the pedit command. So that is, one way is you can right click on the line after selecting it. So you can select the recent input that we have given here, and alternatively, once based on the selected object, you also get the menu specific to the selected object. So here you have the edit polyline command and also other commands that are looked into it. So let us just go into the edit polyline. So now we have this reverse option command. So once you typically give the reverse command, you can see that you don't see any observe major difference to it. So why? Because to enable the reverse command, you need to enable certain system limits. That is, this P line reverse width. So this is the system variable that you have to turn it on to 1 to enable this. And again, to have a better view of it, it is useful when you apply it on a line or a P line that is not symmetrical, because right now this line is a symmetrical line, so you may not come to appreciate the variation of the reverse. So this reverse, actually what it does is, if suppose if the line type is a text based line type, it can change this text orientation, or rather if this line type is of a different line width, then also it can change the orientation, as since it is reversing the vertex order. Let us look into one by one. So first let us try and vary this line type into a text based line type. So towards that, you can go to the line type objects and then try and load a line type that has a text in it. So suppose there is this line type that denotes a text based line, that is, this indicates a gas line that is coming in. So let us load this one and try to apply to this layer here. So now you have got the text here. So let us also change the scale of it to have a better readability. Right. So we have this scale as 5 now. So now we can see that this is the start vertex for us and this is the end vertex, and this is how the text being positioned. So now let's click in it and then go to the edit polyline option and type in the reverse command. So this again you can see there is a little variation of this start and end point, but this would be more predominantly seen when this applies to a P line with a varying length. So let us create one P line and try and edit the width of it. So we have this width command wherein, we'll let us go into the so let's create a new polyline command, and after specifying the start point, let us specify the width of selection. So let us specify the start width to be 1 and then the end width to be 5 to create a tapered line. So now you can see this taper effect here, and when you select this P line and then click on the edit option, the P edit line, and then now you click on the reverse, you can observe that the direction has been flipped in. So this is how your command for the reverse option will work. So next let's look into the edit vertex option. So for its understanding, let us go back to this linear line type. So with this, we'll see how we can make use of the edit vertex option. So after selecting this option, going to the edit polyline. So as it's a single object, you have this edit vertex command highlighted. So once you do that, you will get a submenu of different variants of this edit vertex option selected. So first you have the two buttons that will allow us to select which vertex point needs to be edited. So it is highlighted by the X mark here, and when you go about the next command, so then you can look into how it cycles between various vertex. So if you want to go back to the selection, the previous one, you have to use the previous vertex. So this is done by your next and previous to cycle across the points. Even if it's a closed polyline, if you keep on cycling to the next point, it does not go to the start of the next point. So this is the start point and an end point. even though it's a closed circle, it won't come to this point. So we have to select it individually and then do the task that is required. So suppose let us position at this point. The next command break is similar to your break option. So that is, once you click on this, now this polyline will get divided into two separate polyline segments. So once you click on this, you also again have an option to fix in what point of operation do you want. We can cycle internally here also, or if you want to execute the command at this vertex, then you have to click in the go command. So once it's done, let us come out using the exit command and see how it has reflected. See, on that vertex, the object had divided into two different polylines. So this segment is also a polyline, whereas this is also a polyline, but that has been divided as two. So going back into the polyline command again, edit polyline for the edit vertex option. So now next what we have is the insert vertex command. That is, you can select a new vertex for insertion. Suppose if you select this vertex as insert, so now the first point is retained, whereas one more vertex has been constructed and through which the polyline has been adjusted to it. So based on the selection methodology, we can select new vertex and then AutoCAD will plot the P-line automatically. So next we have the move command. The move command, what it does is, based on the selection of the vertex, we can specify a different point of origin for it. So based on this, now you can see now the vertex has moved, and so the polyline has also updated and redrawn to the actual point. So next we have the region option. So it acts similar to our region command. The thing is, this option is most often used when we are using the width option. That is, when you control the line width here. So based on this, you can specify or modify each width of the segment separately. The difference between the vertex width versus the overall width is that when you click on the width as here, you get the same command as in what you get for a individual polyline width command. Whereas if you edit the in the p-edit option, when you edit the width of the polyline, it is applied uniformly throughout all the segments of the polyline, wherein with the edit vertex command width you can specify separately. So now with this as starting vertex, now suppose if we give the starting vertex width as 1 and the subsequent next segment vertex is linked it. Suppose if we keep it as 3, or to have a greater impact, let's keep it as 10. Now you can see this source vertex has been edited to a width of 1, and the end vertex, that is the next vertex point, has been updated with the distance of 10. Suppose if this command is not visible, if the changes are not visible, then we can use this region command to regenerate the entire polyline. So next we have this straighten command. So as the name implies, the straighten command is used to straight a segment of a polyline. So the first requirement is that we need to move the X marker to the starting segment from where we want to start the straightening, and then have to select the straighten option. So first let us move the point to the next zone. So considering this arc segment we have to straighten, so now we have set the X mark to the starting segment of this. Next let's use the straighten command. So next we'll give the go line. So as you could see, the immediate next segment of the polyline has been straightened using this. So we can also use the command what we saw earlier, that is next and previous, within the straighten submenu to change the selection of the point. But anyway, this has to be positioned on the start of the polyline segment that needs to be straightened. So next what we have is the tangent option. So this option is used for the user to attach a tangent direction to the current vertex, so that it can be later used in a curve 15 methodology. So we'll look into it now. So this is, suppose if we give the tangent vertex direction to be in this way. Next we'll come back to the overall menu and then use a fit option to it. Now let us go to the edit vertex and specify the, okay, let us go to the edit vertex and go to this point. So as we had already mentioned a tangent here, so now this segment has been drawn along a tangent with this line based on the angle that we have specified. Suppose if we want to vary the tangent angle, so subsequently the fitted curve line has also been updated. So this is how we can control the fitted curve option to set a tangent to the specific direction that we require. So this concludes the edit vertex option of the pedit command. Now let's look into the next manufacturability command, that is fillet option. So before going it, let us erase all the selection here, and now let us try and draw a rectangular plate of some arbitrary dimension. So out in the field, that is, if we want to manufacture a plate, then this plate has a safety risk that is associated with it. That is, these corners, these four corners are sharp edges, so that might inflict any damages or hurt the operators or the users, the end users. So in those cases, and also this is in a safety concern, and in a structural concern, these sharp edges possess the stress concentration points. That is, if this material is subject to stress, then the stress energy will get accumulated in this and it's prone to failures initially. So most of the designs that we manufacture, they have to avoid all sharp edges at all costs for these two causes, that is, for preventing any safety concerns and also to improve the structural strength of the material. Those cases is where we use a fillet, that is the trim of the edges in a curvilinear manner, or if we want to trim off the edges in a linear manner, that's called as a chamfer. So chamfer we'll look into the next part. Right now with fillet we'll look into. So if you could recollect, in rectangle command we also had an option to specify the fillet of it, but rather if you have not used that and if you want to use it independently, then you can invoke fillet by the F command or fillet. So once you do that, the first requirement is to select the object. Also we have other menus, that is to undo the setting that we had made, or we can rather apply the fillet to a polyline and then specify the radius of fillet. Next, to whether turn on or off the trim command, and then finally to apply this fillet to multiple objects. So these are the different options that are available with fillet, and let us just go ahead directly and then select an object to see how it reflects. So you can see, once the requirement of this fillet is to specify the first object and then followed by a second object. Even though this is a singular object, when selecting the command using a fillet, you can see it is prompting for a first and second objects. But right now, even though applying this, you can see there is no variation of fillet. Why? Because once we invoke this command, you can see in the command line what is the default setting that is carried over. So the current setting is the mode of fillet is in trim mode, that is in trim on mode, whereas the radius of fillet is set to 0. So now let us go ahead and update the radius. Suppose we keep a radius of 5 mm, and now the first object of selection is required. So this is the first object and this is going to be second object. So once done, you can see that the fillet has appeared onto the edge of the application. So once applied, you can see that the fillet has been applied to the edge of this object. So this fillet will apply to the selected object only. So in order to apply this fillet command for all the edges, you have to go for the internal fillet command of the rectangle. But right now for this fillet, it all considers only two line of objects. So this is the first method of doing it. So the next method to select whether the trim option can be selected or not. So for that, let us draw a line to have it in more detail. So now let us invoke the fillet command again and specify the radius of say 20 units, and selecting the first object and then selecting the second object. So now this radius has been applied with a 20 mm distance. So this is the fillet command with the trim command on. So let us invoke back the fillet command again, but rather go for an undo option, or rather we'll go for Control C on the overall to undo it. Now using the fillet option and then selecting the trim command. So now the default selection mode is a trim method, wherein let's see how a no trim will act. So using this, again you select the first and the second object, but now you can see that the edges are not trimmed and only the fillet is obtained. So this is the option to use the trim command.